Hello everyone, plus two here. We are doing 2025 Scholarship Calculus, question 1D. I find this question quite challenging. Let's try this. Let z equals RCIS theta be a complex number with r is greater than 1 and theta is in between 0 and pi over 2. Let the point A represent z in the Argand diagram and the point B, C, and D represent the complex numbers z bar, 1 over z, and IZ respectively. If angle ABC equals 60 degrees, you better say pi over 3 instead, right? We don't mix them up. If angle ABC is pi over 3 and BC is 1.5, find the area of the quadrilateral ABCD. Use the Argand diagram below to support your working. So start with Z, which is A, equals RCIS theta, right? And it says B is Z bar, right? So which is RCIS minus theta, right? So I'm gonna write here conjugated Z, right? And then C equals 1 over Z. So 1 over Z equals C, and that is, so 1 over Z is equivalent to Z to the power of negative 1, right? So according to De Moivre theorem, that will be R to the power of minus 1 and CIS minus theta, isn't it? Right? So I explain again. So if you go Z to the power of negative 1, that means R to the power of negative 1 and CIS minus 1 times theta, which is minus theta, right? That's the one. Now, IZ. So IZ is D, right? So that is, this is a bit hard. I times RCIS theta, right? So which means I times R. So I'm trying to change this rectangular form. Cosine theta plus I sine theta, right? So which is R, when I multiply by I inside, that's R times I cosine theta minus sine theta, which is R minus sine theta plus I cosine theta, right? So, well, to change back to CIS form, polar form, we have to change sine to cosine, cosine to sine. So first of all, minus sine theta is equivalent to cosine theta plus pi over 2, isn't it? Right? And then cosine theta is equivalent to sine theta plus pi over 2. All right. Then we can write back to polar form, which is R CIS theta plus pi over 2. Okay. So that was hard bit. Then, do you remember the question says BC is 1.5? Okay. So let me draw this. So approximately, say we don't know R yet. So say R is here, A is here. Then B is a reflection of A on X rear axis. So B is there, right? So A is there. And C must be on the somewhere here, 1/10 of origin to B is an OB. So C must be somewhere here, right? Same angle. And A, OA is like this, right? So actually, we can put a line there, right? Like this. Now, it says angle ABC is 60 degrees, which is pi over 3, right? And then we would know that's like a right angle triangle, right? So this angle, so same, this is pi over 3, right? Because they are just like this triangle is isosceles triangle, right? So that one must be pi over 6, isn't it? And that one must be pi over 6 as well, right? That much we know. And then D, let's say D somewhere here. So that should be 90 degrees, right? And D has R. So that length and that length are the same, right? That's kind of a rough sketch. So then, because we know BC, so that length is 1.5, we can figure out what R is. Well, we find out what theta is, first of all, which is, I'm going to write it down here. So theta equals pi over 6, right? And then let's find out what R is. So how we find R is that the length between R, which is, let's say this is O. So length between OB and OC should be 1.5, isn't it? Because BC is 1.5, so I can write this equation, R minus 1 over R equals 1.5. So let's times by R on both sides. That makes R squared minus 1 equals 1.5 R. And R squared minus 1.5 R minus 1 equals 0. So you can times by 10 and factorize it, or just use graphics calculator. Will give you R equals 2 or negative 0.5. We all know R can't be negative, right? Because it's modulus. So R must be 2, right? So now what we can do is we can convert these to rectangular form. Okay, so A equals 2 CIS theta over 6, right? Do you remember A? So we set A there, right? So 2 CIS theta, which means 2 times cosine, oh, sorry, what I'm saying, pi over 6. So 2 cosine pi over 6 plus I sine pi over 6, right? So when you calculate this, you will have a square root of 3 plus I, okay? Because cosine pi over 6 is square root of 3 over 2. So times by 2 gives you square root of 3. And sine pi over 6 is half. So half times 2 is just 1. So 1 times I, right? So same way, B is a 2 CIS minus pi over 6, which is a 2 cosine minus pi over 6 plus I sine minus pi over 6, which gives you square root of 3 minus I, right? C is half times cosine minus pi over 6 plus I sine minus pi over 6. That is a square root of 3 over 4 minus a quarter I. And then D is 2 times cosine pi over 6 plus pi over 2 plus I sine pi over 6 plus pi over 2. Yeah. So that is 2 minus half. So plus square root of 3 over 2i, which gives you minus 1 plus square root of 3i. Now what we can do, we draw this according to this. So D is minus 1 plus 3 square root of 3i, so on. C is this, and B is that, and A is that, right? So we draw this again. So what I'm gonna do is I will rub this out. That was a sketch to understand what we are doing. Now, I will say A is what was A? Square root of 3 plus I, which is square root of 3 is like a 1.7-ish, right? And then I, so A is there, right? And then B is right there, right? So I can put a line there. C is square root of 3 over 4 minus a quarter. So hence C must be somewhere there. Okay. And then D is minus 1 plus square root of 3i, so which is somewhere there. So that's D. So we join them together. So we have to find this area, A, B, C, D, right? So my suggestion is, my plan is, chop this quadrilateral into 2 triangles and find triangle ABC and triangle ADC, add them, all right? So as you know, this angle here was, how much was it? Pi over 3. So we can use, we know the distance between BC, which was 1.5. And we can find AB because we know all the coordinates, right? So surely we can find the lengths between AB. And triangle ADC, well, we can find AD and AC. We don't have angle yet, but we can use cosine rule, right? So find the AC first, and then angle ADC, right? Hence, use triangle rule, area of triangle rule, to find triangle ADC, area of triangle ADC, I mean. All right, that's my plan. Okay, so it is a tedious question. First of all, line AB is 2. How do I know? That's right there, because this is I and this is minus I, right? So add up the 2. And then BC is given, which is 1.5. And the CD, well, we have to work that out. Square root of 3 over 4 plus 1 squared plus square root of 3 plus a quarter squared. That gives me 2.446. And then AD is square root of 3 plus 1 squared plus 1 minus square root of 3 squared, which is 2.828. And then finally, AC equals square root of 3 minus square root of 3 over 4 squared plus 1 plus a quarter squared gives me 1.8. All right. Now let's find angle ADC. Where is ADC? Here, this angle. Okay. So angle ADC, use inverse cosine rule, which is cosine inverse 2.446 squared plus 2.828 squared minus 1.8 squared over 2 times 2.446 times 2.828. That gives me 0.6819 radians. So hence, triangle ACD first, which is half times 2.446 times 2.828 times sine 0.6819. I'm going to calculate that later. And triangle ABC equals half times 2 times 1.5 times sine pi over 3. All right. So triangle ACD should be 2.1798 and triangle ABC is 1.299. Hence, the quadrilateral ABCD should be add up to 3.4789 units squared. All right, cool. All right, that was interesting question. All right, I will see you next time. Bye.